Hi everyone. This poster is about superconformal indices for wrapped D3 branes. And in particular, we consider two different setups for this purpose. The first setup is the four-dimensional superconformal field theories, which arise as the world volume theories on these D3 branes that are placed at the tip of the Calabi-Yau threefold cone. And in the second setup, we instead consider the wrapped D3 branes as the point particles in the corresponding quiver quantum mechanics descriptions, which gives the effective dynamics of sufficiently far apart D3 branes. So the first setup can be thought of as the generalization of the well-known holographic duality between an ADS5 cross S5 background on an type 2b string theory with n equals 4 super Yang-Mills theory. And the generalization corresponds to replacing the S5 factor by a more general Sasaki-Einstein 5 manifold. So we start by writing the superconformal index for this boundary theory and then consider its giant graviton expansion, which essentially captures the finite n-term corrections to the index for the classical supergravity, which is denoted here by I infinity. And the second term here corresponds to the giant graviton index. It is the giant graviton index which accounts for the wrapped D3 branes on supersymmetry preserving 3 cycles in the Sasaki-Einstein 5 manifold. So we find that the large wrapping number asymptotics of this giant graviton index is given by the master volume formula for a variational family of metrics over a Sasaki-Einstein manifold. So this class of geometries previously appeared in the literature in the context of externalization problems in the bulk, but now our results suggest a physical interpretation for these geometries as near horizon geometries for giant gravitons. So the next setup is the quiver quantum mechanics picture for this wrapped D3 branes, and in particular we consider the effective Coulomb branch in this quiver mechanics, which is already well known to capture the multi-centered BPS solutions in the corresponding n equals to supergravity. More precisely, we consider an additional limit, which is some sort of deep scaling limit in the quiver mechanics, which zooms into the intersection between the Coulomb and Higgs branches. And in this limit, the quiver mechanics becomes conformally invariant, whereas in the supergravity description, it corresponds zooming into the ADS2 throat region for the black hole. So we proceed to compute the superconformal index for this superconformal mechanics, which is a very non-trivial task and involves implementing regularization and resolution techniques since the target geometry is a cone. However, it turns out that it can still be computed as a character-valued Dirac index on the result space. And then we can apply supersymmetry localization techniques to compute this index. So these are the things that I want to discuss in more detail in the poster sessions. Thank you very much.